We've seen that variables and boxes can do the same thing in this example. So whether I let x be a variable, change it before calling the function, or whether I let x be a box and I change the content of the box before the function looks in the box, in both cases the function sees a change, we get a 7 out instead of a 6. We might ask though, in general, are boxes more expressive or are variables more expressive? Can we write more patterns with one or the other? And at first it may seem that boxes are actually more powerful because a box is a value and we can pass it around. For example, I could create a fill function here that's going to change the value of box, and then after that function is defined, create a new box, pass that box into fill, and when I run this program, I will see a 5, not a 0, because fill is able to change the content of the box that's bound to A. If I try to do something similar with variables, I define a fill function that does a set bang on B, I let A be 0, and then I call fill with A. This set bang does not change A. B is a completely separate variable from A. We reference A to get the 0. To bind to B at a new location, this set bang changes that new location. So when we look at A at the result here, we still see 0, not 5. And the difference here is that a variable is not a value. We can't pass a variable into another function like this. It turns out there is a way to turn a variable into a value, and that's by wrapping it in a function. So here I am again letting A be 0. We're going to see a change to A this time, because instead of just passing the variable directly, we are going to pass a function that takes a value and sets A to be that variable. So now the fill function, even though it's defined outside of where A is bound, it's going to receive this B, and instead of doing a set bang, it's going to call the function on 5. That will have the effect of changing A to be 5 instead of 0. So we see here we can get a kind of effect where we can pass something to a function, and that function can make changes, and we can see it as a variable. Like you might expect with boxes, there's a general way of performing this transformation and getting the same thing out of variables, taking variables and getting boxes out of it. Here is a Plait implementation that does exactly that. We're implementing crates, which are like boxes, using only variables. So there's no box and unbox here. There's only set bang on a variable. And this variable v is going to effectively represent a box or a crate. This is the mutable thing that we can look up or we can change. The way we change it is using one of these mutator functions, just like the pattern we saw before. You call this function, pass a new value in, and it'll set the variable to have that new value. Meanwhile, we pair that in a tuple using values. We pair that with a function that just gets the current value. So the uncrate function that acts like unbox takes a crate, it pulls that accessor function out, the first of the tuple, and then calls it with no arguments. So that gives us the current value inside the crate. Or the setCrate function takes a crate, it pulls that second mutator function out of the tuple, and then calls that mutator function with the new value. So that has the effect of changing v to be the new value. So if you call get on the crate, you'll see the new value. Let's try running that a little bit. Here is our crate implementation. Let's let b be a new crate that has 0 inside. Then we can begin and we can call setCrate on that new crate with the number 5. And then if we uncrate on b, we should get a 5 out at the end, not a 0. And that's what we see. So crates here are acting just like boxes, and again the key point is that we implement it without using boxes, but using variables. That means we can get boxes out if we only have variables. We can implement our own boxes this way. The same thing works at the curly language. We already have enough in our curly language with variables to implement crate, uncrate, and setCrate. This pattern is a little complicated because we don't have tuples built into our language. It turns out we can get tuples with lambda, and we'll talk about that more. But what you should see inside here is that we've got a variable v, we've got the getter function, we have the mutator function. Uncrate is, it turns out, pulling that out and has to pass a dummy argument in. SetCrate is pulling it out and passing the new argument v. And here at the end we have that box-like program just before. The only trick is we have to call setCrate with one argument and then another argument, since we only have single argument functions. We'll talk more about that pattern as well. But you can believe that this is a box-like pattern implemented without boxes even at the curly language. And we can run this example This is our curly with variables interpreter. Let's see, there's interp right there. I have set up the example, so this is the same slide as in the code. I'm just parsing it, interpreting it in the empty environment and in the empty store. You see a lot gets allocated in the store because we have a lot of variables and function calls, but the key point here is that we get the number 5 out at the end. We successfully set 5 into the crate and then found the 5 by looking again inside the crate. So the punchline over here is that mutable variables and mutable structures, as represented by boxes, they have the same expressive power. It's easy to go from one to the other by encoding in terms of the other one.